Hello and welcome back to the lecture on applied econometrics. So we have been talking about dummy variable, and in the previous lecture we have seen the reduced form equation, and so far we have been talking about interactive dummy. And in interactive dummy we have seen how that looks like. It only impacts on the intercept, nothing to do with the slope. Now if I want to have the slopes changing, so how we are going to deal with the dummy variable? That is the topic of this lecture. Now we have seen that one assumption we have made all throughout is that the slopes for all the different equations which are clubbed together in the reduced form equation, so far what we have seen, the slopes are constant. So the slopes are same for, in the previous equation we have seen, for be it female, be it male, be it a person a part of union or non-union, be the person is white or non-white. For all the cases the slopes are same. Or in the previous equation we have seen for males and females, if we run regression equations separately using national sample survey data in India, we have seen that. So we have seen that the coefficient of education or experience, they actually change. So what we get for the full sample data, the regression coefficients, they are quite different from when we use a subsample of male and female separately. So that kind of gives us an idea that, well, if we keep the slope constant, perhaps that is somewhat a big assumptions we are making, and we need to look into that. And to address that issue, we essentially bring in the concept of slope dummy. All right, and let me actually show you how it looks like if I use a slope dummy. So it is essentially, there are different types of slope dummy we can have. So let's say I will draw different cases here. So let's say I have, in this case, the first case, let's say I do not have any slope dummy here, only intercept dummy. And if I have intercept dummy, so this is the same equation like we had previously. It is the two lines are parallel, the angle between them is, the slope is basically same for both the lines, and only difference is the intercept delta. Okay. Now if I have this equation is equal to, let's say, some constant term plus some delta into x1, let's say, and some, let's say, beta x2. Okay. So this is the equation of this line, and here since it is reference category, delta is equal to 0. So what I'll get c plus beta x2 for this equation, whereas for the other line we will get, because of the delta value, we will have this equation c plus delta x1 plus beta x2. Now that is the usual case. Okay, so there is no change in the slope. Now when I introduce a slope dummy, things are a little different, and let me actually show you how it would work. So let's say I have, let's say I have drawn the same line here, c plus beta x2, the same line as a reference dummy category, c plus beta x2. Let me actually meet from the left, y is equal to c plus beta x2, and I have drawn the other line, but this time I am actually allowing a change in the slope, and the change in the slope, so here I will have theta and theta 1, let's say, and the change in the slope will come from the fact that I have allowed, so I have allowed the x1 to interact with x2. So essentially the equation is going to be, let's say, c plus delta x1, and there is a coefficient, let's say beta plus beta 1, let's say another beta 1 into, this is beta 1 into x2. So what I have done here? So what I have done here, I have basically included this variable x1 and I have allowed this variable x1 to interact with x2, and because they are interacting, I am actually getting a slope coefficient added, so which is beta 1. Okay, so earlier I had this only this coefficient delta, and now because the two variables are interacting, I am getting another component here, beta 1 x2, which is actually rotating theta, which is actually adding the slope component here. It can go either way, but this is what is happening. So because I am allowing the interaction here, so I get something like beta 1 x2. Now I can have another category. So so let me actually name the diagram. So let's say this is diagram 1, this is diagram 2, and this is diagram 3. Now in diagram 2, what we have done, we have actually allowed both this is the intercept dummy, okay, just like the previous case, and this value is still going to be the same value, which is delta. But in this case, if I want, I may simply want to avoid the slope the intercept component. I can simply avoid the intercept component, and what I can do instead, I can just introduce the slope component here, okay, just the slope component. So how will it be? So let me try to draw it. Let's say the same line here of the reference category. This is theta, and my equation is as it is, y equal to c plus beta x2. And in the next equation, I do not allow this. So if I do not allow the delta component to come in, essentially both the lines actually pass through the same point, because the intercept is basically the c. Okay, for both the line, the intercept is going to be c. So it is the same as in all the cases. Okay, the intercept remains c. But what I am allowing here, I am allowing the interaction term to be present, and that is why the slope is becoming theta 1 here, theta 1. So this is the slope. This is theta 1, okay, just like before, and the equation is going to be y equal to c plus beta 1 into x2. Essentially, what we have done, we simply omitted the intercept term, the intercept dummy. So essentially, these two cases in D2 and D3, what we have seen is that we have allowed the slope to change. Okay, we have allowed the interaction to happen. And to give you an example, like it could be, for example, in our previous case, we had, you know, like different dummy variables like female, we had union, non-union, we had white, non-white. Now, if I sort of try to understand, let's say, the impact of female education, so which should be an interaction between female and education, what would be the impact of female education on the wage? So in that case, I will allow something like, let's say, my dummy variable female into education. Okay, so this is how we will sort of explain the interaction dummy. Okay, and let me actually show you in code how it actually will look like. So we had this equation here, right? Now what I'm going to do, I'm actually going to write another line here. So this was my code. Now here I'm going to do chain, let's say female education is equal to dot replace is equal to, let's say, my education variable and my female variable. So when my female is equal to 1, so it will give some value, but if my female is equal to 0, it will basically give a 0 value. So female education could have some value for female education if the female is equal to 1. So, only in that condition you will get some value, otherwise it will be 0. If it is male, it really does not look into that. So, let me actually run it and let me actually add all these variables in my regression, and here we will have, say, this new variable fem edu. Okay. So, let me run the all the 3 equations. All right. Let us see how it behaves. We have run it and let us see the result here. We got some result. So, let us try to interpret the result. Okay. So, here you see we have, when we included this new variable female education, so we got this value, certain value for female education. Okay. And here we see that this is a value of minus of 0.27, and which is p value is 0.035. So, that is, it is less than my alpha equal to 5%. So, it is going to be significant. So, it shows that if a female is having education, or the impact of female education is going to be 0.27 unit less than the corresponding reference category. So, basically the male education, basically male is the reference category here. Now, so that is basically the impact of female education vis-a-vis impact of male education. Okay. And this is how we should interpret. Now, this is what has happened here is that because of this coefficient, because of this new coefficient term, this new variable female education, your slope of the new regression line will change, right. So, this is how we will understand the intercept dummy. So, we have the contribution for female here, it is as it is like the intercept term, but we have allowed this rotation to happen, this rotation of the line to happen because of the female education coefficient. All right. So, this is how we will understand the concept of slope dummy. Now, I could have very well omitted, say, female altogether. Okay. I could have simply written this. I could have simply written this, in which case, what I would have had is, let us say, I am deleting this female part and I am just including female education. Okay. And if I run it, so what I get is this equation. Okay. We get this equation. So, in this case, what I have done is I have actually removed the intercept dummy. I have only kept the slope dummy. So, this is a case D3. This is basically same as the D3, and the previous one is basically same as the D2. Now with that we got the concept of slope dummy. Now, if I sort of want to understand the impact of slope dummy on reduced form equation. Okay. So, previously we have seen that we had all these different variables, different dummy variables, and we by like putting value is equal to 0 or 1, we get the coefficient terms and we add that with the intercept term, and that is how we get basically many regression equations for different categories, right. And that is only for the intercept dummy. Now, in case of slope dummy, if I have a slope dummy, how do I really interpret my reduced form equation? Okay, how do I really unbox the reduced form equation and get many other regression equations? Now, let us actually see that. So, let me actually go back to my whiteboard and let me create this equation. So, here what my regression equation is, let us say my wage in the previous example, my wage is equal to, let us say there was some constant term, let us say beta 1 plus let us say beta 2 into education, then I had beta 3 into experience, then I had say beta 4 into female, then I had beta 5 into non-white, it was union, correct, it was union. And then I have this another variable that I have added, let us say beta 7 into female. All right. Now, if I Now, if I have to unbox the equation and suppose, female education, let's say female education, right? So, this is the product of female education. This is a slope dummy here. This is a slope dummy. This one is a slope dummy, right? So, let me actually identify, because this is a new element we have included. This is a slope dummy. So, the point is, when I'm talking, when I'm actually trying to get the reduced form equation, and when I'm trying to get, all the different equations from the reduced form equation, so how do I really interpret the, new equation? So, let's say I want to understand for female non-white union, okay. So, how we are going to include the beta 7 here? So, what will happen is that I will have a value for, I will have beta 1, then I will have beta 2 into education as it was, then I will have beta 3 into experience as it was, then of course I will have beta 4 into female, then I have, because I have included female, then I have included non-white, so I will have, actually I could have written non-union, let's say non-union, okay, I can exclude one variable, and I will have one coefficient for non-white, so this is beta 5 non-white, and then I have to include beta 6 is omitted because it is non-union. So, I have to include beta 7 into female education, because this is because of the fact that I am talking about the females, okay. I am talking about the females. So, I have to include beta 7 here. So, that is going to give me the specific regression equation for female non-white non-union category. Now, if I look at only males, then beta 7 is going to be omitted, okay. So, in this case, if I'm actually talking about males, then the beta 7 is going to be omitted. So, this is how we will understand the reduced form regression here, reduced form of the equation here. Now, suppose here we have actually seen the interaction between a dummy variable with a numerical variable, right? Now, I can also have an interaction between two dummy variables, okay, two categorical variable, and let's see how that will work. So, let's say my interaction term here, let's say I want to include a slope dummy for female who are in union, okay. So, then it will be female cross union, all right, female cross union. So, that means only if female, so female can take 0 and 1. So, only when it is female it will be 1, and union can take 0 and 1. So, that will mean only if the person is a part of union, that is going to be 1. So, essentially if we multiply, it will have only one value of 1 when both are correct, female and union. In all other cases it is going to be 0, okay. Now, if I include this in the regression equation, so my regression equation, let's say wage is going to be, let us come back. So, beta 1 plus beta 2 into edu, beta 3 into experience, beta 4 into female. Female is going to be there because we are talking about female. Beta 5, note that we are actually keeping beta 5, let me see, it was non-white, beta 5 for non-white, beta 6 into union. So, we are keeping both female and union dummy variable as it is. So, we haven't removed them, but we are including one more dummy, let us say it is beta 8, because we have used this beta 7 in the previous equation, we can write whatever you want, beta 8 female union, okay. Now, you will include beta 8 only if I am asking for someone is interested to know the impact of both female and union. So, if and only if you are interested in the impact of both female and union, you will include beta 8, but in all other cases, if it is male, beta 8 is going to be 0. So you basically don't include anything. Or if it is female non-union, this is going to be 0, okay. Or if it is male union, it is going to be 0, okay. So or female non-union, so all other categories are going to be 0. Only if female equal to 1 and union equal to 1, you are going to include beta 8. So for if I finally want a wage equation for, let me use a different color, wage equation for female union, say wage for female union, and let us say white, female union white. So I will have beta 1 plus beta 2 edu, beta 3 experience. Let me reduce the size a little bit. Beta 3 experience, then of course beta 4 female, and because it is white, so beta 5 is going to be omitted. Beta 6 of course is going to be there because we are interested in union, and then the beta 8 female union, okay, female union. But had it been male, so this term would have been 0. I would not have included it. Had it been female non-union, I would have excluded beta 8. So this is how we will understand the reduced form equation when we are including the slope dummy. So one thing that we have to sort of keep in mind in this case is that so here I have only used say 1 or 2 slope dummies, so female education, female union and so forth. But if I actually allow all the possible combinations to be present, for all the interaction terms, so then it is going to be something like what we have seen for subpopulation regression. So in that case, the male equation for the male population and the female population, as we have seen in the national sample survey data, that is going to be same as the same dummy variable equations if we manage to introduce all the different slope dummies, okay. So this is basically the idea of slope dummy, and we are going to see that actually how to introduce slope dummy and how many slope dummies to introduce and how it is actually going to become like our normal regression of subpopulation regression. That we will see in the next lecture, where we are going to talk about the test, different kind of test, and like sort of to understand the basically the best model when you use a dummy variable. So with this we end this lecture here. Thank you.